Say I have a line on a grid, maybe down here, here's point C and maybe here's point D, and I want to know the distance between them. How can I find that distance? Yeah, you can just count, right? So this has a distance of 5. And if I had something like maybe E and F.
Can we write these?
Yes, please.
Oh, okay.
If I had E and F, what's the distance?
3.
3, right. If it's vertical or horizontal, we've got no problem. It's easy to see what the distance is. But what about from A to C here?
A.
Inches?
I'm sorry, A to B. A to B. No, just, how about, what measurement did we use here and here?
Units.
Units, right. Blocks,
Yeah.
units.
Okay. 3/2.
There should be 4.
Is it 4? Okay, let's see if it's 4.
2, 3.
So I'm going to take and I'm going to use this as a measuring stick.
Can we use our sandpaper?
Yeah, if you want.
Yes, I am.
So I'm going from the corner to point A there. Let's see if it's 4.
It is 4.
So if I move this, where that corner's with B, I don't think that's 4. It's more than 4.
Man.
Why?
Because it's going
diagonal lines are longer.
It's the longest side.
4 and 3.
It's the longest side of a what?
Hypotenuse.
It's the hypotenuse of a right triangle. Where's the right triangle?
Right there.
On the opposite side.
Here?
No, other. It can.
Here.
Well, I mean, it can be, but like.
It could be either side.
Let's make it both sides and see what happens. Yeah.
Let's don't. Let's just, how about we just make it one side because of time.
Okay.
So let's make a right triangle. Which side you make it on is not important. But when you make that triangle out of that diagonal, it gives us the ability to calculate the length of that side because we know two sides of a right triangle. This is a 2 and a 4. So we're going to use the Pythagorean theorem. I don't have a lot of room here for it. I'm going to try to make room here. Remember a squared plus b squared? Where 2 and 4 must be what? A and B, good. So this side that's missing is C. So we're going to say 2 squared plus 4 squared equals C squared. And we should be able to do that in our heads, I think. 4 plus 16 equals C squared. And if I keep going, 20 equals C squared.
So then you.
Take the square root. That's a great question. What is the root of 20?
Well, it's like 4 point something.
You're right. It is 4 point something. So here there are two ways I want you to answer this question. What's the exact answer? And what is the estimated answer? So the exact answer is C equals the square root of 20. That's exact. If you put the square root of 20 in the calculator, I suspect we will get,
4.47.
yeah, we're not going to get quite, oops. Yeah, but see this, here's what you need to know about a square root like this. This is irrational. There's a lot of irrational numbers in the world. What I mean by irrational is it's like pi. It's never ending and it's never repeating. So we can't write it as a fraction. It doesn't repeat. It never repeats and
Actually,
it never.
I know like some just. Like,
Okay,
I just can't.
Riley.
3.1.
I'm trying to teach a class here. Okay. Okay. So we're going to round this to the nearest hundredth place, which would be 4.47. So we say C is about 4.47. Is it exactly that? No, it's exactly the square root of 20. But that's a value that we really can't use in the real world, so we have to do some rounding on the digits. So we can use the Pythagorean theorem to find the length of a side of a line segment on a grid. All right, so let's look at another one. Let's look at experiment 3. It's on the next page. So, same problem. Anytime there's a line that's diagonal, if it's horizontal or vertical, we're in good shape. But if it's diagonal, our distance is probably something that's maybe going to be a little weird. So let's make the triangle. You can make it on top or you can make it on the bottom. It doesn't matter. I'm going to make mine on the bottom.
This looks so big.
We've got a right triangle here. And so I've got, this is 2, this is 5, and this guy is, what don't we know?
C.
C. We don't know C. So fortunately I've got some room here. I'm gonna write it up here. So we can say the two short sides, the sum of the squares of the two short sides, so 2 squared plus 5 squared equals C squared. And 2 squared is 4. 5 squared is 25.
Oh, 29.
Yeah. And you're right, it's going to be a little bit more than 5, right?
0.3.
Okay. I want you to go to the I want you to go to the hundredth.
5.38 something.
So what's the exact value? C equals? Right. That is the exact value, which is about, let's see.
Guessing 5.
So do you guys know how to get the square root on your calculators?
Second.
It's second, right? It's the blue key. It's second. And then on the left side, it's just above the x squared there. So second and then x squared gives you the square root. And then you just put the number in. The older style calculators, you just put the number in and then you hit square root and it gives you the answer. But these guys, you put it in, it looks just like it. So this would be 5.39. 9, because the 5 is going to move the 8 up to 9. Remember, if the next digit is 5 or more, you round up. If this number here was a 4, no, 5.39.
But would the 8 make the 3 and 4?
No, because I'm rounding to the nearest hundredth, 2 decimal places.
Okay.
Okay, so I've got to look to the 3rd decimal place to decide where to round. So 5.39 is our closest to the 100th place. All right. So you're going to have some problems today that involve just doing that. You're going to use the Pythagorean theorem. Just make a right triangle. Let's look at the first page of the Ready, Set, Go. As far as I'm concerned, unless you need more practice, that task is done. These are just like the 2 that I went over. Watch out for number 4. It's a little tricky. I'm not going to give you any hints. I want to see what you guys can come up with. Okay.
I got you.
So flip to the next page.
Okay, wait, where? What page?
It's the next page up. It's the set.
I see it.
6.2 set. Let's do a couple on this page. So number 5, if you look at number 5, I'm going to start actually down here. It says graph a line parallel to the given line, but before I do that, I'm going to write the equation of the given line. I'm going to do this first. So that means I'm putting it into y equals mx plus b. So my b is -2, and my slope from here to here is up 2 and over 1. So I'm going to say y equals 2 over 1, or just 2x minus 2, right? My slope and my y-intercept. Don't forget the x. People always forget the x, and without the x it doesn't work. So you got to get that x that's multiplying the slope. Now, we get to graph a line that's parallel to it, and you get to pick wherever you want to put it. The only thing I'd say is don't put it there, right? It's parallel and it's the same line. Let's make it somewhere else. So pick a y-intercept that's different than -2. I'm going to pick, I don't know, 4. Okay? You pick whatever you want. You don't have to pick 4. Yeah, you, Edie. Wake up. Wake up. All right. So then this one's going to be parallel. So the slope is going to be the same, 2 over 1x, or just 2x. But I'm changing the y-intercept. You change yours. You can put it wherever you want. So when I graph that, I'm going to use the same slope. I'm going to get tricky. I'm going to use a straight edge here because I want to make it pretty. But if I was just making it for myself, I really don't care. So the thing that this wants you to notice is that parallel lines have the same slope. Right, they have the same slope. The y-intercept will be different unless they're the same line, but then they're the same line, not really sort of parallel. So you get to pick, put them wherever you want, just make them parallel and write the equations. So these equations could be different for everybody. These guys will be the same here. Let's look at number 8. Because the problem we worked over, I think it was 12 and 13 for the review, those of you that asked for that, is based on this. So I'm going to do the same thing. They want us to graph a perpendicular line, which means that they meet at a 90-degree angle. This is the symbol that we use for perpendicular.
So is that, wait, what would you call it? Hold on. The opposite reciprocal?
It is. So let's start with the equation for this line. So I've got 1 for y-intercept, and it looks like my slope is up 1 and over 3, 1/3. All right, 1 is my intercept, and I'm going up 1 and over 3 to get to the next point. Is everybody okay with what I've written there?
Yes.
All right. Now, same thing. You get to pick a y-intercept that is whatever you want it to be. In fact, in this case, because they're not parallel, you could even pick 1 if you wanted to. I'm going to pick something different. I'm going to pick -4. So my equation, before I even graph it, my equation is going to look like this. Y equals, I flip this fraction and make it opposite, so it's going to be negative. And you could just call that -3 if you want. That's totally cool. In fact, that's a little bit more basic there. -3 is fine. And I said that -4 was going to be my y-intercept, so I'll write the -4. But if you picked something else, that's totally cool. So I'm going to go down 3 and down 3 and what can I do? Up 3 and back 1, right? Up 3 and back 1. So if I did everything right, my lines should be perpendicular. Let's test it. Let's see, where did my thingy thing go? Here's a thingy thing. Does that look like it's 90 degrees? I think so. So how do we make perpendicular lines? Opposite reciprocal slope. Right, you flip the slope. So perpendicular lines have opposite reciprocal slopes. If I misspelled reciprocal, I'm sorry. Complain to my English teachers. They're probably mostly dead.
Oh my lord. I don't think they're probably not. They're probably really old.
How old do you think I am?
They're probably, okay, I'm guessing your teachers are probably in